And then we have in here, if I just leave it like that, this is ethylene. This is the ethylene group or ethane. And then if I put some here and here, and then in the other one I'm gonna put it. I should have. And here, hydrogens. Okay, so these are hydrogens and these are fluorine. And then I minimize, and then I go into here, and it is not available, but I would like to know if there is a dipole. And before, what is this one? Good students. Oh yeah, it says in here. It tells you where is polar. And then you want to do another one, and then let's just, I think it's easier to do the, let's go back in here. And then if I want to erase one of these ones, I just, no, let me show you something cool. I'm gonna, this is one of the isomers in here, but I'm gonna make the other ones. So, this is something nice about the Spartan that makes your life a little easier. So I want to change the fluorine atom by the hydrogen atom. So I have the selected here the hydrogen atom. I just click, double click, and it changes. You see it? And then I double click here. Oops. Yep. And I change it, and then I go again, minimize, and then I see my properties, and it tells you what is here. Right? And it says what it says here. Cis. And then you see the infrared spectrum of this. This is pretty cool. Okay. So we can see these vibrations in here. And this one's. Okay, let's go back to where we are. And did I show you the dipole moment?
Yeah.
I forgot. Yes?
Yeah.
Of this one? Okay, now I'm gonna change. And then I'm gonna change here by hydrogen. Is this polar? I don't know. Let's see. Is this polar?
No.
No. Wow. And it says over there, polar surface area 0. And this is the trans, right? And so you can very easily identify one from the other. And look how different. And then we click in here. Okay, so this is some of the nice things that we have about Spartan that makes your life easy. And then I'm just going to close this one. And I discard, and then I'm going to open. We have some, anybody knows what enantiomers are? Oh, the lights again. Goodness. And I have more enantiomers here. I open enantiomers 2 and enantiomers 1. Okay. Can you see them? Why is this doing that? I've been here too long. Okay, so again, what are enantiomers? Mirror images, right? Like my hands. And so it's very difficult to do it, and it's very difficult to figure out if it's the R or if it is the S. Or OChem students, it's very difficult to figure it out. And so in here, you just click and it tells you. So you go in here where it says model, and then configure, and then you see the RS. And so when there is the, it's okay, is where it tells you if it is R, is not. And it's also very easy to change from one to the other. You just double click. Okay, let's change. Let's see if I can do it in here. in here? No, because I have two of them. I have to have only one, and then I double click. If I want to move only one, I can do that. Right? I can click in there if I want to move only one, or I can move it. Now, be very careful. I use both Mac and Windows, and the shift and the control, they are a little different from each one, so you have to experience, but you know, you are so good. It's like you don't read the instructions when you are playing video games, do you? No, okay. So let's see if I can do it. No, I cannot do it here. But you know, from changing from one configuration to the other, RS, when you have only one molecule, you just double click in the carbon, and the carbon, and then it changes from the R to the S. So you don't have to do it. Isn't that nice? Yes. Now let me just show you the last example that I'm going to show you is our friend what? Yeah, so what about it? So we start this, I started this presentation telling you that we scientists, we chemists, we observe materials around us, we observe substances, compounds, and then we try to think, we try to put a model, and try to understand what is happening at the microscopic level. So, here is water, and well, yes, water, very nice, so water what? So that's okay, yeah? I have water, and I have my infrared spectra, and here is polar, very nice. So what? Well, let's see what happens. Why ice float? There is something happening with this mouse. Oh my goodness, look what's happening. What are all those lines? If I put one over here, it's too far, or if I get it close. And I'm going to put another one in here. And so I'm putting more and more. And what are those?
Hydrogen bonding.
Hydrogen bonding. Wow, and it's telling me down here how many water molecules I have. So I have 26 water molecules, and let me put a little more over here. A little more, and then yay! And then you can see what is what you see. So the contracted, expanded. Oh, so when I have a solid water, what is happening? Yes, and then the density is less. Thank you, private student. And so you see these holes in here, and that's the reason why ice floats, because of these holes that are formed with this hydrogen bonds. Now I'm going to get a methane, and the methane I'm going to put it right in here. Okay. Is DNA's polymerase, DNA polymerase, and so we can see here the different structures. So the primary structure, you know what is all the groups, one by one. You cannot see it now, I will show it in a minute, but then you can see the secondary, right?